Finally, we get to talk about strings. And I'll start by saying that strings are an array of chars that are terminated with a null. As you can see here, a /0. Now, that's a really big explanation, and I'm not going to dive into it. I'm just going to show it to you. I'm going to dive into it in my next chapter when I talk to you about how strings are stored in the memory. But the first thing I'm going to do is just want to explain to you how to use strings, how to use the tools that are available for us for strings, all the functions, and so on. So let's dive into string. If you find this video useful, please like it and share it and subscribe to my channel. Another thing I must say before we dive in is that a string is an object and not just a data type like integer and char. And the reason for that is that you can apply specific function on that object that are a part of the object. It's basically in C++ and not pure C, because pure C only have an array of chars. And after confusing the hell out of you, let's dive in. So this is the ways that you can set a value into a string object or a string data type. You can see the basic and most common used one is to open a double quote. Note double quote versus single quote as we use in chars. And the reason for the double quotes, this is the difference, is telling the microcontroller now that we are about to give him a string and not just one char. The second thing is to use the string constructor, which turn things into string. What it does basically is just add a null terminator in the end. Doing here is really unneeded because it's just doing the double things. You already declare this as a string, and it's, I don't know why they gave this example, but it's here, so I copied it. It's copied it from Arduino, and I wanted to copy it as is. If you want to mix two strings, you can do it by doing a plus between them. You can turn numbers like the 13 into string. Of course, you could put here an integer that its value was 13. As you can see, turning an analog grid into decimal, it's a really comfortable way to do that. Turning a string into its hexadecimal format, turning a string into its binary format, and then again taking millis, turning them into decimal. And another nice thing here is taking a float with 3 digits after the decimal point and printing out all the 3. Now let's go see the result of this. So I copied the example from this location. This is the URL. I'm going to put that in the description as well. One thing I've changed is the baud rate, which is my preferred baud rate. And as you can see, they're doing the same thing as I showed you in the example, and then just printing the thing out. So I've already uploaded it, so let's open the serial communication and see the actual result. And here are the unsurprising result. Hello string came out as hello string. A, this is a string, string 2 plus with more, they got this is a string with more. String of 13 will show up as 13, the analog grid was 418, the hexadecimal of 45 is 2D, the binary representation of 255 is 8 ones. There was it was 3 millis from the moment I started the Arduino. And as you can see, the string of the float here is 5.698. Excellent. So now let's move on. So as I mentioned before, string is an object. And since it's an object, it's got functions. Now let's go over the really important ones that we can use while working with strings. The first one I'm going to show you is chart@. Chart@ returns the character at the position that is listed within the brackets, and in this case 0. I think I've mentioned that before. Arrays start with 0, so the first position within an array will be 0. So this will return us the letter L, because we are taking the chart@ from example at position 0. Now the second function that I'm going to show you is set char@, and again I'm giving a number and I'm giving a char, so that's going to replace the char that is in the first position, the 0 point, the first position within example with a big L. Now note something really important here. Some of the functions return a value, like example chart@, so you can actually print it out or do I don't know, char c equals example chart at 0, and then c will gonna be in small l. But some of the functions do not return a value and are just functions, they're a void. Therefore, if I'll try and do serial print example set chart at 0l, I'm gonna get a compiling error. The next function is concat, which basically adds this string here to this string here. And it's the same as doing examples equals examples plus second string. But that's an easier way to do that, and it's a function. Next one, ends with and starts with, which is exactly what they do. They check if they will return a true if example ends with whatever is in second string. And the same goes with this. It will return a true or false if the string starts with whatever the second string is. And I'm going to show you the examples running in a second. Next one is we can change all the string into lowercase, meaning let's say I wrote something and I want it all to be in lowercase. I can do it in one function. And again, note here, I have to do third string dot to lowercase and not print it out, because this will actually change whatever is within third string. Same goes for uppercase. Now you can see I'm connecting to strings here, is what I said, the same as concat. And now I can do index of, and I'm looking for second string within example. I'm looking for the first index when that's gonna appear. And last index, that's the same thing, just starting from the end. And again, I'm gonna show you the result. It's gonna be much easier to understand. Length will return the length of the string. Remove will remove from this index this amount of characters. Let's say that I have something that I want to remove the characters between 2 and 4. So I'll have 2 here and 4 here. Actually, I'm going to have, sorry, that's my mistake. It's going to have 1 here because we said from the second characters, and we said array starts with 0. So the second character will be position 1, and then we want to have 2 here because we just want to remove 2 characters. And in this case, I'm just removing the index of second string from example by the length of second string, basically removing second string from within example, which I've edited before in one of the previous examples here. Compare to would compare this string to that string, and I'm gonna go over this a little bit better, compare in another section. We'll talk about exactly about comparing and how to do that in string. A substring will return the substring from 0 position, 4 characters, and it will give it to you as a string. So you could basically do string, new string equals this. Last few things is to do with turning them into numbers. You can turn a string into integer. Now, if this will be, let's say, for example, 12a, you're gonna get 0 because 12a is not an integer. Also, you got here floats. You can turn this number, well, this string, sorry, into an actual float. And we have replace, which replace this string with this string within this string. Wow, that was confusing. And the last one we're gonna have is trim, which removes any unnecessary spaces like this and this from the start and the end of a string. So we have example, which is let's talk about strings, and we have second string, which is yippee. So example.chart at 0 will be lowercase l. As I mentioned, it's the first character within example, which is the lower l. Now, if I do example set characters 0 to big L, example is now let's talk about strings with a uppercase L. Now, concat second string into example, the result is going to be let's talk about strings EP. Now, example ends with second string. Second string, as I said, is EP, and since I've added it to example, the result will be 1, which is true because it does end with EP, Well, it does not start with EP, therefore we're getting 0 on this start with. Now I'm taking third string and I'm giving it example. I'm giving whatever is an example, which is now, let's talk about strings EP, and I'm setting it to the same value. Now I'm taking it to lowercase, and it's gonna be all in lowercase again. And to uppercase, now you can see it's all in uppercase. And again, this is the string itself, the object itself that changes. Now, example second string plus a space plus example will give us EP, and then we got few spaces here. Let's talk about strings EP, yay! And now index of second string, the first index will be 0, since as you can see, example is all of this string, and second string is EP, and the first time that EP is represented within example starts with position 0, as you can see here. And now if we look at example last index of second string, it says 32, because this is position number 32, and you can count if you like, but trust me on this one. Example length is 39, so all of this length is 39 characters. Now look at this, example remove. As I mentioned, you need to put a starting position and how many characters you want to remove. What I did here is I've took the last index, the last index of second string within example, same as I did here. So basically I could have written here 32, and then I took second string length, and this is the length of EP. And as you can see, the result of it is the same string as before, just without the EP in the end. Hooray! Example compared to second string, we're getting 32. And as I said, I'm going to go into depth when I'm going to talk about comparing and string, which is the next subject. Example, substring starting with 0 and 4 is EP. As you can see, it's starting with 0 and it gives you 4 characters. Now, third string equals 12, and then I'm doing int equals third string into integer, and I'm getting a proper 12. The third string is 13.657, and I'm turning it into a float, and I'm getting 13.66. And the reason for that is that I'm printing it out without printing 3 digits, and I've gone over this in my previous tutorial. Third string is yes, we can do it, and as you can see, I'm replacing it with that and ending a result with yes, we can do that. And the last thing is, and I forgot to write here what I'm doing, is basically I'm trimming it. As you can see, the first time I'm printing it out between 2 asterisks without trimming it. And the second time I'm printing it out with trimming it. As you can see, it removes the unnecessary spaces from the start and the beginning. So now let's go back to comparing strings. And I've took this example out of the Arduino site, and I'm going to put that in the description as well, the link. Now we have 2 strings, string 1 and string 2, and we start comparing between them. We can do a regular compare like we would do with an integer or a long, and we can compare one to the other. We can also check if one string is not equal to the other. And you can see here they're doing it with putting this, and then they're doing if it's equal or not, and this way. And the second thing they do is to use the equals function, which I showed you before, and now they're showing if string 1 is equal to string 2, which is not. And the reason for that is the string 1 has a uppercase T and string 2 has a lowercase t. And for that we have equals ignore case, which ignores the case if it's upper or lowercase. It just looks at the characters themselves. You can see here it's doing string 1 to integer and comparing it to an actual integer. So again, using one of the functions and comparing it with an actual integer. You can see here they're doing comparison as in greater or equals to. And you can see here strings. Now, very important, when you're doing numbers, the numbers will go accordingly. So if you have just 1 digit here and 1 digit here, that's really, really cool and no problem. But if you do this, if you do 1,999, For you, 1,000 is bigger than 999, but 999, which is the first character, because what we're doing here is comparing characters within the string. 9 is bigger than 1, therefore this string will actually be bigger than this string. Just so you know, it's really important to remember this part. And here they're doing it with strings. So basically what they do is they take the strings within the ABC and checks which one will come first, which will come later, if you needed to sort them by the ABC. Here is another one which is compared to. Compared to is it's a bit tricky to understand. What it does, it takes string 1 and compares it to string 2. And the result will come out as a number. If it is a negative number, then string 1 will come before string 2. If it's a positive number, string 1 will come after string 2. Now let's run this example and see the result. Now let's look at the results, comparing to the actual code. So you can see string 1 equals this, and if it does, we're printing this out. It is. Now, is string 1 not equals string 2? Yes, it is, because you can see we got this not equals that. And now we're changing the two values, and we're again comparing one to the other, and we'll say they're not equal to each other because we got an uppercase and a lowercase. This not equals to this, and again because of the uppercase and the lowercase. And when we do equals ignore case, it's okay because it is the same word, just with different cases in here. Comparing the to int 1 to the number 1, it is true because we get a printout. As I mentioned before, 999 is bigger than 1,000 because 9 will come first, because we're looking at it as a string and not as a number. Carry on, Brown will come before Charles because B will come before C. Brown is bigger than Adams because A will come before B, and so on with the rest of the things. The last thing I wanted to show you was the one with compared to. As you can see, cucumbers comes before cucaracha, and that's because it is, you have CU, and then an M, and here you got a CU, and an R. So you're going to get a negative number because this will come before this. Few last functions that I'm going to cover now, and I'm just going to cover it a little bit because they're going to need a tutorial of their own for the reasons of the null-terminated array and so on. So bear with me. To char array will take a string and create a char array out of it. This will be the variable you're going to put the array in, and this is going to be the length. Same thing you got with get bytes. We'll do the same thing, just return bytes instead of a char. C-string will take a string and turn it into a C-style string. And the last one is reserve, which will reserve a place in the memory for the string. And again, I'm going to go over it in my next tutorial when I'm going to talk how strings are stored in memory. And last thing that is a bit unrelated yet still is you got string character analysis, and there's a lot of really nice function. Is alphanumeric, is alpha, is ASCII, is white space, is control, is digit, is graph, is lowercase, is printable, is punctuation, is space, is uppercase, is hexadecimal digit. And I'm going to give you the link in the description as well, so you can go over it. There's a great example here of how you can use it. And this is for chars. It's semi-relevant, but I wanted to show you, and I had nowhere else to put it. I hope you enjoyed this tutorial, and get ready for the next one, which is going to explain to you how things are stored in the memory and how things are behaving in C.